Hello, everyone. Welcome to MLAS 200 Introduction to Automata and Cybernetic Systems Theory. So, we're going to get this kicked off with three things. First, an overview of the course structure in Canvas. Second, we're going to do an overview of the syllabus. And then third, we're going to run through our first lecture. So, let's go run through the first part of this agenda, which is getting through the Canvas course and getting familiar with everything and where things are located. So first up, very similar to MLAS 200, or excuse me, MLAS 100, very similar to that, same style, same structure. Homepage, we're going to have our regular updates here on the homepage, syllabus and information related to that. You can find over here on the left-hand side. Information, course number 19044, credit hours 3. Course starts 10/17, ends 12/16. Prereq, of course, MLAS 100. You've got Dr. Sri and Dr. Mike here to help you through this whole process. There's our contact information right here, as well as any announcements that we end up making, you'll find out here. Modules, and I'm going to run through these just to give you a high level. We've got our learning activity 0, and that's what we're going through right here now, but we also have Introduction to a Cybernetic Project Kit. That'll be your kickoff in terms of getting familiar with the hardware. The difference between MLAS 100 and MLAS 200, of course, is not just in the content, but also the differences. MLAS 100 is very lecture focused. MLAS 200 has lecture and lab. A lot more heavy on the lab. So we're going to be dealing with the microbit microcontroller. And you'll learn a little bit more about that in the next video, which is focused on introducing you to the Cybernetic Project Kit. After that, you've got your, we get this show on the road with peculiarities and uses of cybernetics. Transformation, repeated change, determinate machines and vectors, as well as coupling systems, feedback, and independence. And then we round out the first 3 weeks with stability and system stability as it relates to disturbance and equilibrium. Then we come up to our first quiz, and that wraps up week 3. Then we move into weeks 4 and 5. We talk about isomorphic, homomorphic, and automorphic machines. We get into the book to a certain extent. There's some topics that we have to cover around automata theory that aren't covered in the book. So we'll tackle those in learning activities 7, 8, and 9. We talk about combinational logic, finite state machines, push down automatons, as well as Turing machines. I do spend a bit of time in Turing machines, so that's something that you'll get a lot of familiarity with. Turing machines create a very good framework for us in terms of autonomous systems and ways to describe autonomous systems. You learned about the categorical nature of autonomy when we talked about the gradients of autonomy in MLAS 100. We're actually going to put a little bit more meat on the bones in this particular case by talking about Turing machines in more detail. After that, we get into regulation and control, entropy and noise within a system. We also get into parallels with biological ecosystems. And then we'll be starting our last bits of our projects, which are our lab projects that we have, we've got a smart car, as well as some fun with a tricorder. This is your wearable kit that is part of your CPK. After that, we have a cybernetic research paper, and that pretty much wraps up the course. That'll bring us up into the end of December. After that, you'll either be taking MLAS 350. I think most of you will be taking machine learning and data structures, as well as probably your first foray. For some of you, it may not be everyone, but some of you will probably be focused on unsupervised learning as well. So those will be some things on the horizon past this course, but that gives you an overview of MLAS 200 from a Canvas perspective. So let's talk about the second agenda item, which is the syllabus. So our syllabus here is the standard one. It's our contact info, as well as the textbook that you're going to be using, which is going to be an introduction to cybernetics. This is a Ashby book, and we will help you with the readings through the Ashby book. There are a lot of parallels to our lectures as it relates to the Ashby book, so you'll get a lot of good explanations as to what cybernetics is and how it relates to autonomous systems. Okay, now on the other requirement outside of the textbook, you'll also want to have the Cybernetic Project Kit acquired by this time. So this is the Freenove Ultimate Starter Kit. This comes with the microbit. If you by mistake get the Freenove Ultimate Starter Kit without the microbit, no worries, it's okay. Just make sure you buy the microbit. You can buy them separately. What's really nice about the Freenove Ultimate Starter Kit is it comes with everything that you need. But it just depends on the situation. If you're on Amazon, you're poking around, as long as you get the Freenove Ultimate Starter Kit, you should be in good shape. We also have the do-it-yourself programmable wearable kit. You'll want to make sure that you do not need, I will say down here where it says purchase 4 CR2032 batteries, you will have CR2032 batteries with the wearable. They come in that kit. But it is a good idea. So it's optional, but it is a good idea to grab a couple more because you'll be. I personally had a lot of fun building the what we call it's essentially we build a little tricorder for one of our final projects. It's a fun little project, kind of a Star Trek-y kind of thing, but it's very, very it kind of gives you an idea of how small a modern tricorder would be as opposed to the big ones you saw in Star Trek. So that'll be a fun project. That's something that you'll be on the lookout for as we get towards the tail end of class. Now, one last thing you want to get is you don't have to acquire it right now. There is a coding robot card kit. So this is a Yaboom BBC microbit based car, and this will give you a feel for doing it's full autonomous systems, I would say, in a mini sense. It's not like a Tesla, of course, but it's a very good introduction to a complete autonomous system in the sense that you'll put you'll be using the microbit as the microcontroller to make the car do line following exercises, but also to do object collision avoidance, not really object detection, but collision avoidance, some basic things that you can do with a autonomous car. And at least gives you the basic principles. Now, we aren't technically doing any machine learning, but it does ease you into, we're not using any machine learning algorithms with the microbit robot car kit. With that said, there are some what we'd call very basic expert systems AI that is going on, and we'll talk about that more when we get towards the tail end of class. You do not need this robot car kit until the 6th week, but if you want to go purchase it ahead of time, feel free. You can get that in the 1st week, but we really won't be tackling it until around the 7 week mark. Okay, the rest of this is pretty straightforward in terms of the course. It's really broken up into 3 big areas: mechanisms, automata and entropy, regulation and control. Those are your big areas as it relates to the course overview and themes that we'll be covering in the course. The rest of this in the syllabus is boilerplate, electronic communication. The majority of you have been in my MLAS 100 class, so same rules apply. MLAS 200, reach out to Dr. Shree or myself via email. You can text me as well if you've got any questions. If there are any questions in terms of the syllabus, definitely reach out to either one of us. Okay, that wraps up our syllabus. This brings us to our 3rd agenda topic, which is our lecture. So let me go ahead and get this rolling. Here we go. So this is our learning activity 0. We did the course introduction, but I also want to do this and bring you up to speed on what is cybernetics, and I'll blast through some of this because we've covered pieces of this already. If you look on the right, that's actually a picture of Norbert. He was the original progenitor of cybernetics and cybernetic systems theory back in the 1940s. We are running off of our book is based is written by Ashby a little bit later, which actually refined the concepts of cybernetics. AI and artificial intelligence and cybernetics were born out of what's called complexity theory and complexity sciences, and they actually used to be very commingled from like the 40s, 30s, 40s, 50s. And then when the 50s kind of hit, things kind of they diverged. Artificial intelligence went a different way, and cybernetics kind of went off into a different direction. We're finding that they're actually starting to come back together here in the 2020s. So it's something that is a great time to be around, because we have all these new technologies that allow us to do artificial intelligence, but also we have these new technologies that allow us to do cybernetics. So the hardware is allowing us to explore artificial intelligence, as well as the miniaturization of hardware and microcontrollers, allowing us to do even more fancy things when it comes to the principles of cybernetics. Okay, so we talked about the syllabus, talked about the course news, we talked about the modules and the course files. So we went through that. This is just a visual of that. So we're going to be, of course, running everything through Canvas. Course resources. This is required software. Of course, you need Adobe, PowerPoint, Word, Teams. Those are all things that are helpful. We'll also be using Microsoft MakeCode. Textbook, I talked about that. Ebook, there is a PDF ebook that you'll be using for your labs that helps supplement what we're doing on the lab side. Cybernetic Project Kit, I talked about those pieces. And then, of course, the autonomous car that you'll be getting in the 6th week. Okay, course projects. So in the Cybernetic Project Kit, we actually have quite a few. So we've got Cybernetic Feedback Project, we've got infrared motion sensing, we got ultrasonic ranging. I forgot to mention it in the video in the CPK Kit overview, which you'll see in the next video, that there's an ultrasonic sensor as part of your CPK kit, so we can actually do ultrasonic ranging. We also have a wearable digital, which is the tricorder. We have that Cybernetic Project robot car. We also have, of course, MakeCode for block coding. But what's nice about MakeCode, we also make references, although it's not required, it's optional. You can explore JavaScript and Python as it relates to MakeCode. So it gives us a good springboard into CMST 247, where you learn about JavaScript, as well as your data structures course that Dr. Shree is queuing up for us in the next semester, which is going to be really heavily focused on Python. So this MLAS 200 course actually gives you a lot of good grounding in those bases as it relates to the programming languages that you're gonna be seeing. Okay, so here's a few things. A couple of course myths dispelled. So just right up front, just want to let you know, when you look and get the book, you're probably going to be freaking out. I know I would be if I looked it up and went, oh my gosh, look at all the math. There is a lot of math in the Ashby book. Now, with that said, I do a lot of dispelling of the math. We're not going to be, there's not going to be a huge amount. There's not going to be any algebra we cover in the math. In the class, rather, we leave that up for the math classes. But we will cover a little bit, but it's more conceptual and then architectural. It is still it's a non-programmatic course, but we still do some programming. So that's to dispel myth number 2. It is a non-programming course, but we do what's called block coding. So block coding is technically not a type. It's a very basic form of programming, but it's nothing that you can't handle. But this eases you into, for people that are new to programming, block coding is fantastic because it eases you into the main primary structures of programming and how that relates to what we do in the course and what you'll be doing in future follow-up projects. So this is a good way to ease you into the more advanced programming languages like Python, JavaScript, Java, C, C Sharp, all those other different languages that you're going to get some exposure to in our program. So last one is we do in fact take all of our machine learning autonomous systems students. We do cover two theories. So just as a high level, we have automata theory and we have cybernetic theory, and those two together make up the base core parts of what you're gonna learn, and it's going to in this course but give you a frame of a lens to view the world through these two different theories. And trust me, when you go through this course, you get through the training, you're going to see the world very differently, because we use different languages. We challenge you to think through things a little differently. We actually challenge you to think of yourself differently through this course specifically. So definitely be open as you move through this. There'll be some interesting ideas and concepts that we run through, but they're necessary as you get on to the next steps as the program evolves. Okay, so I believe that brings us to the final part of what I want to talk about. That wraps up our introduction to the Learning Activity 0 and the high level of the course. I'm excited that everyone's here, and I look forward to working with each and every one of you through the course. All right, we'll see you in the next learning activity.